All right. Avenue code day 10, here we go. Let's get our input, bunch of integers. And let's make this a list of integers. Great, we got a list of integers, and it's not that long, actually. Interesting. Okay. Each of you... Any given adapter can take an input of 1, 2, or 3 jolts lower than its rating. Okay. Okay. Ooh, okay, so this is a little bit more complicated. Like we have to actually do some serious reading to make sure we understand what's going on. Okay, so charging outlet produces the wrong number of jolts. Make a list of all the voltage adapters in your bag. Output voltage or puzzle input. Each given adapter can gain input of 1, 2, 3 jolts lower than its rating still produces rated output voltage. Okay, so that's good to know. In addition, your device has a built-in voltage adapter rated for 3 jolts higher than the highest rated adapter in your bag. Okay. That's the built-in adapter. Okay. Effective voltage rating of 0. Time to kill. You might as well test all of your adapters. Okay. 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 Okay, so this looks like we just sort it. Okay. Um, always has a difference of 3. Okay, so I'm just gonna L.append L of -1 plus 3. And then we need to figure out all of the differences. Difference of 1. Okay, so we also need to L dot insert oops. Okay, so now we have the 152 and we have the 0. So now for I in range, 0 L minus 1, and we want to say diff 1 is equal to 0, diff 3 equal to 0. Actually, just do this. Diffs equal to 0, 0, 1, 0, 2, 0, 3, 0. Actually, we don't need this one. Diff is equal to L of I plus 1 minus L of I, diffs of diff plus equals 1, and then we're going to print diffs. Here 0. this should be a minus. Oops. So 65 times 29. Okay. Complete determination. Oh, wow, okay. What's the total number of distinct ways you can arrange the adapters to connect the charging outlet for your device? Okay. This seems like something that can be broken into subproblems really well. Um, hmm. So my guess is we need to write a function, def num ways of, and we're going to say adapters, or let's just call it nums, why not? And what we need to do is do something recursive. Um, hmm. The other thing we need to do is okay. Yeah, okay, so this is definitely a recursion problem that we need to memoize. So we need to remember, let's actually not have this, and then we're just going to say which index you're starting at. And then we're going to memoize, and we're going to say if you start at a specific index, ants is equal to this, and then we say if I in ans return ans of I, else, and then what we want to do is print ans of 0. So now what we need to do here is actually figure out the logic. So if we're looking at index 0, we need to look at the next 3 things, and then we're going to sum those, I believe. Let's see here. So while L of I is less than, or let's see here. J is equal to I, while L of J, let's see here, J, I plus 1. While L of J is less than L of I plus 3. Wait, can it be up to 3? I believe it can be an up to 3 difference. So it's less than or equal to. Total is equal to 0. Well, we need to have a base case somehow. So if we just have just the last thing, a little bit annoying because we have to, the base case has to do with hitting the end of the list. You know what I really want to do? I just want to take a slice of the list and then work with that because that's going to be easier, I think. Okay, so we still want that, but now we want to say L slice equal to L of I to the end. And so we're going to call num ways of 0, and then we're going to print answer of 0. Well, actually, no, we just print. Sorry, I did this a little bit wrong. Num ways of 0. Great, that's what we want to do. So now what's going on is we've got num ways of I, and then if I is in the answer, then return answer of I. Otherwise, let's take a nice slice of our list, and our list is going to be starting at index I and going to the end. If lang L slice equals 1, return 1. Else, we don't need the else, but I'm doing it anyway. I'm not doing the else. I actually kind of like that. So, if our length of our slice is 1, then return 1. Otherwise, it's just annoying to deal with these like different cases and stuff. I'm trying to figure out the best way to do it. We've got total is equal to 0. So, okay, so we've handled the case where it's just one thing in a list, because then we just get this, and we return 1, and it's fine. So let's think about the case when there's 2 things in the list. When there's 2 things in the list, then our I is the second to last thing, J is going to be the last thing, and then, let's see here, let's just add an and, J is, or is it here, while J is less than length of L. I don't think we're going to be using, well, I guess we're using it here, and I don't want to deal with fixing that yet. So while J is less than length of L, and L of J is less than or equal to L of I plus 3, total plus equals num ways of J, return total. Well, that's running for a long time, which is not good. Yeah, we probably got some sort of... Ah, you know what we didn't do? We didn't increment J. Well, we are now incrementing J. Something's not right. I don't know if we're... Ah, we're not caching our answer here. Ands of I is equal to total. A. Wow, nailed it. Cool. Well, let's see how fast people did these 2 puzzles. 2 minutes for both stars. That's nuts. And then 8 minutes for the top 100, and I took about 15. So a little bit slow today, but it is what it is. And I definitely should have gotten this bit faster. It seemed more complicated than it was. Like just reading this thing. Like there's so much text to just say, hey, like figure out all the differences, and then there was the like, oh, well, then you've got that thing at the end that can be that is exactly 3 volts more, and then the thing at the beginning which is exactly 0. Oh, that was a lot. Okay, so um let's clean up this code because there's no reason for our code to be this ugly. So our diffs is we're just keeping track of them here. I wonder if we have, are there any differences of 2? I'm just curious. Print diffs 2. No, there's no diffs of size 2. I don't know why that is. Is that something they specifically said? 1, 2, or 3 jolts lower than its rating. So there's no I see. So there's no differences of 2 like between 2 things, but there's differences of 3 here, and then there's difference of 1, and then a difference of 2 between 17 and 19, for example. And that's where like the interestingness in this part happens. So I think I'm actually pretty happy with this right here. I think this is simple enough. The L dot sort made things pretty simple. Yeah, they weren't sorted. And so let's print our part 1 solution. And then for part 2, this is just what we're memoizing, so we've got the answer. So the only place we're using L slice is here, and so I just want to say if length of L minus I, so if I is the exact last index is equal to 1, then return 1. I think this should be fine. Yep, got the same answer. Excellent. So total is 0, j is equal to I plus 1, while j is less than length of L, and well, I honestly think this is about as concise as it gets. Because so the magic sauce here is where we say, okay, so let's just say j is the next element in the list, and we're just going to iterate through the elements of the list until we hit one that is more than 3 greater. And we just count the number of ways starting at that index, and we add that to our total. And once we start hitting repeated computations, so like these things at the end that get computed over and over and over again, because we're trying to count the number of ways from 147 every single time I'm doing any one of these things, it's going to be doing lots of recursive calls to these things at the end, and those all get memoized, so they don't have to recalculate it. Like if we print ands here, wait, that's weird. Oh, it was just... Why isn't it printing? Oh, because it's before we do the calculation. Duh. Go away, please. Sorry, I'm pressing the wrong key combination. There we go. So yeah, so now we see, starting at all of these different indices, these are all the different number of combinations, and it all stacks up to this massive thing here, where it's just 1, or 2, or 4 for these last ones. Wow, that's a lot of exactly 7 right there. But yeah, I'm pretty happy with this. It was a little bit slow compared to some other people, but you know, can only read so fast. All right, well, see you next time.